Good morning. My name's Sophie. I am a maths tutor and founder of Tutor in a Box. And today we're going to be looking at algebra. Now, algebra is the one topic that whenever I go through it with my students, they always go, oh, it's hard, it's boring, it's rubbish, and they say lots of other things like that. Well, I'm here today to try and disprove some of those things so you can do it and that it actually isn't too bad. And so we're going to recap some of the basics. Okay, there's one important thing you need to know for algebra, okay? And all algebra is using letters instead of numbers. So when we don't know a number, so if something's 5, but we don't know it's 5, then we just replace it. And we use it with X, Y, Z, T, B, S, E, any other letter we want. Yeah, the idea is always the same. We replace that number with a letter. Let me show you some examples. Okay, so examples of algebra are 5t, 3x, 2b minus 5t, 9g minus 6. Yeah, it doesn't matter what it looks like as an equation or a line or an expression or whatever. The most important thing to remember is that with algebra, we're just using some letter instead of a number. Got it? Fab. So, then the first thing we need to know is some basic notation. So, A times B equals AB. You'll see this quite a lot. We put two numbers next to each other and it means we times them. So for example, RF means R times F. Easy peasy, right? Let's give you one more. ED, which, surprise, surprise, just means E times D. Got it? Perfect. Now, let's start using multiple letters and numbers. What about 6TR? Well, in the same way, that just means 6 times T times R. We've got all those letters next to each other. It just means time. All right, let's try another example. If we have a letter times the same letter, we get it squared, okay? So, T, for example, times another T equals T squared. And this is something that a lot of my students struggle with. All squared means is we're just timesing something by itself. So when we square something, we times it by itself. So if I've got A squared, it just means A times A. If I've got D squared, it just means D times D. Now, let's look at a more complex example. If I have D F squared, what does that mean? Well, all it means is D times F times another F. Because remember, F times F gives me F squared. Easy peasy. All right, let's now start looking at simplifying, okay? So this is a word that you might hear that comes up a little bit in algebra. Simplify an expression. And all this means is collect like terms and make it smaller, make it easier, make it simpler. So, for example, I have x minus 3y plus 5d minus 2x, okay? All it means by simplify is collect the similar terms. Simplify. So, if I look here, I've got minus 2x and an x. So if I highlight these, that x and that minus 2x are similar. Equally, that minus 3y is on its own, and the 5d is on its own as well. So we can only simplify that to minus x, let me do this in blue, minus x minus 3y plus 5d. Now, I went through that quite quickly, so let's take another look. The x's and x's are the same terms, okay? And it means that we can do something called collecting like terms. We can collect things that are similar, so we can group them together. Now, if we group minus 2x plus x, we just get minus x. So that's where that first bit comes from. I haven't got any other y's, so I can't do anything with the minus 3y. I haven't got any other d's, so I can't do anything with the 5d. And so all I can do is simplify the x's. Let's take another look. So I'm making these up as I go along, so you'll have to bear with me if I'm thinking on the spot, as it were. Okay, perfect. So we've got another expression, and it says simplify. And again, all that means is collect like terms, collects terms that are the same as each other. So go back to our drawing. We've got an x here. We can collect that with, woo, that circle went a bit big, with the minus 3x there. We've also got a plus 2y, and we can collect that with our minus 1y. They're both y, so they're like terms. Let's look at t's now. So we've got minus 5t and minus 3t. They're both t's, so we can collect them. And finally, we've got r by itself. Okay. So now when we try to simplify this, we look at all the x's first. So if I'm looking at the orange bits, the orange circles, I've got 4x minus 3x. Well, let me do this in the blue. I've got 4x minus 3x. Well, if I've got 4 lots of x and I take away 3 lots of x, I'm left with 1x. So that becomes 1x. Let's take a look at the y's now. If I've got 2 y's and I'm taking away 1 y, I'm left with 1 y. So that again becomes plus 1 y. Let's look at the t's. So this is the bit in blues. I've got 5t and I'm taking away 3t. That means I'm left with 2t. So it's going to be plus 2t. The r's are by itself, doesn't have anything to go with. So we just put minus 2r. And hey presto, you've simplified an expression. Well done, you. Okay, the next thing I want to move on to now is talking about substitution, okay? Again, this is a part of algebra that some students really love. Some students think it's a long word that they don't understand. The trick with substitution is just to think we're given a number and we just plug it in for the letter. So, for example, a question might say, substitute n equals 5, or 6 in the equation. Okay, so we might get a question that says something like substitute in, and then it will tell you what it wants you to substitute. So it's giving us an equation here, which is n plus 3. So we've got our equation n plus 3. And then all it's saying is substitute n equals 6 into it. So we just get rid of the n and we pop the 6 in. And then we can just work it out. And that equals 9. Voila, we've substituted it. Let's have another go. So, bit of a trickier one here. 5n plus 2, and again, we're going to substitute n equals 6 in. So, as before, it's going to equal 5n plus 2, but we're just swapping that n for 6. Now, can you remember that when we said we had two letters next to each other, we times them by each other? So 5n just means 5 times n. So when we're substituting that 6 in, it's just going to be 5 times 6. Now, if we work that out, 5 times 6 is 30, plus our 2 gives us 32. And voila, we've substituted in a number instead of a letter, and we've done substitution. Very good job. All right, the final topic I'm going to talk you through in this part of the algebra webinar is going to be expanding brackets, okay? Now, I absolutely love expanding brackets. I think it's a really nice, easy concept, and you get to smile, okay? So that's the trick here. So, let's say I've got this example, x minus 2 and x plus 3. I'm going to start with double brackets here, so we're going to go straight into it, okay? So with double brackets, you might have learned at school something called FOIL, first, outside, inside, last. Alternatively, I'm going to teach you a new method, which is to smile, okay? And we're going to draw a face. So step 1 is to draw an eyebrow. Step 2 is to draw another eyebrow. Step 3 is to draw a little smile. Step 4 is to draw a gigantic smile. And so as you can see, we've drawn lines from different bits to other different bits. Let me give you another example. Okay, so again, we're going to do the same thing, but this time it's an orange. So that's going to be step number 1. We just do x to the x. Then step number 2 is my second eyebrow, which is the 5 to the minus 7. Step number 2. And then step number 3, ooh, that went a bit awry. Step number 3 is our little smile. And that's because sometimes we don't have big smiles. And then step number 4 is a big smile because we all love doing algebra, okay? So that's the drawing out of it. Now, once you've got those lines, all we're going to be doing is timesing from one thing to the other. So let's go back to the first example. Here, we had x to x. That was our first line. Now, x times x, if you can remember from earlier, if we're timesing x by x, we get x squared. So we just write x squared. And that's our first one done. Then we do minus 2 times 3. And that gives us minus 6. Now be careful you don't put 6 there. A negative times a positive is always a negative. So remember that one. Then we look for the little smile. Minus 2 times x is just minus 2x. So we put minus 2x. Then we do our big smile. We do x times 3, which gives us plus 3x. Now, as we learned earlier, we can simplify terms that are the same. So these x terms we can group together and simplify so that we end up with x squared minus 6 plus 1x. Because if I've got positive 3x, so plus 3x, and I take away 2x, I'm left with 1x. All right, let's have a go and look at the orange ones. So looking at the second step, x times x gives me x squared 5 times minus 7 is minus 35, because remember, a negative times a positive is a negative. So we put our minus 35. That's a bit of a big 3. And then for our third step, we draw a little smile and we do 5 times x, and that's a positive 5. So it's going to be plus 5x. And then we're going to do a big smile because we all love algebra. And so that's going to be x times minus 7. So it's going to give us minus 7x. Now, as before, excuse me. Now, as before, we can join and simplify the x's. They're the same term, okay? So we can make this x squared minus 35 minus, woo, pen went a bit funny, minus 2x. So we've got x squared minus 35 minus 2x. Because if we've got minus 7 and we're plussing 5, we get that negative 2, which is where this end bit, negative 2x, comes from. Now, once we've got that, we tend to just rewrite them. So it becomes x squared minus 2x minus 35. Woo! And you'll see why we do some of that later. But the important thing is we get them in order. We get the x squared terms, then the x term, and then the number term. So I've gone through today a little bit about what algebra is, substitution, and expanding double brackets. Hopefully you've learned something. Hopefully you've enjoyed it. And I will see you back here next time to learn more about algebra. Bye.